This is a derivation of the quadratic formula, and we are going to start with just a quadratic equation. I will start with a very general ax squared plus bx plus c is equal to 0. And my only assumption here is going to be that the value of a is not equal to 0. And I think that's a pretty fair assumption, since if the value of a was equal to 0, this would not be a quadratic equation. It would be a linear equation. And also we are going to complete the square here, so I'm going to make the assumption that you have a basic knowledge of completing the square. So what I will do is begin by rearranging some things. So I am going to move the value of c over to the other side of the equation, and I am going to factor the a out of both sides, of both terms that are on the right side. So what that will give me is a times x squared plus b divided by ax, and then I'm going to leave some space here, and that is going to be equal to negative c. And you should pause for a second here just to make sure that what I've done is okay. If I multiply in this a times x squared and then a times b over ax, you should recognize that I will get ax squared plus bx plus c. Now I want to complete the square on this part of the polynomial, and what we do when we're completing the square is take that linear term, which is b over a, the coefficient of that linear term. We're going to divide it in half, so I'll multiply the a by a 2, and then we square it. And that is what is going to get added here. So I'll write it as b squared divided by 4 times a squared. And then I need to make sure that my equation still holds. So since I added that to the left side, I need to add it to the right side as well. But I need to keep in mind that this has been added inside of the parentheses, and it's being multiplied by the value of a. So what I really added to the left side of the equation was a times b squared divided by 4 times a squared. And clearly I'm going to be able to cancel the a's, but recognize that what I actually added to the left side of the equation was this term here. Now, if we clean things up a little bit, I now have a times x plus b divided by 2 over a squared. That's the way that this much, what is inside of the parentheses, is going to factor. That is going to be equal to, let's see, the a is going to, one of those a's is going to cancel, and I'll write it in a different order so that it's b squared divided by 4 times a minus c. Okay, then get a little more space here. I will divide both sides by a to give me x plus b divided by 2 times a squared is equal to b squared divided by 4 times a squared minus c divided by a. And I'd like to take this that's on the right side of the equation and make it into one term. So I need to multiply the bottom of this by 4 times a. So I'll multiply the top by 4 times a. And then that on the right side will give me b squared minus 4 times ac, all divided by 4a squared. And if you are familiar with the quadratic formula, you should begin to see it taking shape here. So x plus b over 2a squared. Now I want to get rid of that squared, so I will take the square root of both sides of the equation, which will give me x plus b divided by 2 times a is equal to plus or minus the square root of b squared minus 4ac, all divided by 4a squared. Let me work on the right side here a little bit. I could make that the square root of the top, which is b squared minus 4ac, divided by the square root of the bottom. The square root of 4a squared is 2 times a. And then I'll take the b over 2a and move it over to the other side. So that'll give me x is equal to negative b divided by 2a plus or minus the square root of b squared minus 4ac, all divided by 2a, and conveniently those have the same denominator. And so I can put those together and get the quadratic formula, which is x is equal to negative b plus or minus b squared minus 4ac with the square root all divided by 2 times a. Ta-da!